So here is another project I worked on for a little while. So for a couple months, well, a little bit more than that maybe. But it's a blockchain entirely written on JavaScript, and this system can be expanded, so you don't have to only run one blockchain, one chain for one specific function, but you can actually extend it and have 10 chains or 10 blockchains. And each one is running then on also a different port and is not influencing the other chain. So if you wanted to, you could like separate it and even like run just one blockchain on one server, the other blockchain on a different server, or 5 blockchains in one server, 5 blockchains on a different. So like you can separate things, which I think is good and important, so that not everything has to be on a main chain, right? So like not like Bitcoin where everything is like just in one chain, but rather like you starting to decentralize it or like break it down a little bit further into like having different chains for different purposes. So yeah, that's something I was working on, but let's just get started. So let's install everything we need, which is Node. Node version manager would be good, and then npm, the package manager. So let's install these things. Okay, this is running now. Then we'll just copy this. This will download the repository from Git. So let's do this, git clone. I might have to, okay, there might be like a typo in there. So we cloned that, then let's go in the folder and we do a npm install that gets all the packages that we need. That might take a little bit, so it can take like 5 minutes or something. And then we should be able just to start it up. So, and there's an interface. So it's not just pure, not just the back end, but also like a front end that actually has modules to communicate with the back end. So that's all in there too. So the packages are installed. Now what we do next is gonna change something. We're gonna open a file explorer, or like in my case, I just use Kate. Then we go into, for example, chat, config, and config.js. You will see the network ID, which is a unique ID, like it's being generated off the Genesis block. So that gives the network a unique ID. So we're gonna remove this as a test. So you can, when it doesn't have an ID, it generates a new network automatically. Otherwise, if there's already a network ID, then it knows, okay, there's a network to connect to, and otherwise it would like create a complete new Genesis block if you don't have it in there. So, but that's what we want. So we're gonna take the network ID out. So we're gonna create a complete new network. Then we're gonna go into Node. We're just gonna enter Node dweb. That's gonna start up the framework or the system. So, and then what we see right out of the gates, we see some wallets. Wallet file not found. So it generates wallet files. Here we can see that we created a new network. So that was for the chat. So it created a complete new network, new blockchain for the chat module. And yeah, so like if you don't have a wallet, it creates a new wallet file also just for your node. that's specific for your computer or for the node if it validates transactions. So, and then the next thing is to go on the actual front end. So we're going to do HTTPS. And we're going to enter this. Then we can accept the certificate. Because it's a local certificate, it's not going to have anyone, no authority signed against it because it's locally on your computer. So you can just proceed. Then the next thing is we have this interface, and we generate a new wallet. We can copy the private key or the phrase, but we're just gonna, for now, like enter something as a password. Okay, now we created a wallet in the browser, and now we got the chat here, and that's basically where our chat network is. And when you, this is one entry, so this is being sent. So we'll see it here too. So if we scroll all the way down, and as we type it, let's see, there was a new block, and it got confirmed. Obviously it's got confirmed just with the local computer because it is a completely new network and there's no peer or anything. But yeah, so it got validated, and then it's in here. So we can also take another look into how that looks within the network. Do that again. So there we go. So there are two things we're gonna do too. So like we're also getting the last block hash. So and the account nonce that prevents issues with the ledger. So like double spending or like double entries or something. So by getting the account nonce, we can make sure that like the next entry is really the meant to be the next entry, and we have no duplicate entries. But the main thing then is we have a send action, and with the instruction type is chat message. To account is the channel, the message is encrypted, and yeah, amount is not really necessary, neither is fee. It could be added, but at the moment it's just in there without any actual fee that's being deducted from an account. So then you have the nonce, which increases each time. So next is nonce 3, and then the last seen block hash is basically the last block hash that also helps prevent keeping transactions alive forever. So by having a last block hash, we can make sure that it links to a previous one. So essentially we're just extending the instruction interface. So whenever we want to make a new blockchain that has its own instruction, so let's say it's not about a chat message but a file upload or whatever, you would just extend the I instruction, and then that instruction could be used with a different via RPC, so with an API call. So yeah, then you can also have a look maybe at the blockchain to give more of an idea how this is. So as you can see, we have like all those different like networks, and they're all individual like blockchains. But right now, like, let's go into chat. We're using our account. We look our account up, and then we see like, okay, so like there are different chat messages that came from it, or instructions. And yeah, if you look into it, then you have the nonce, you have a timestamp, you have the block within it's contained. So if you look into the block right now, we would only see one message, but there can be many actions or many different actions from different users. So there could be like 20 different chat messages or something, because like the block can contain more than one instruction. So yeah, but let's go back into the user. Then yeah, we'll see the history. That's the past. So let's do a little speed test. Okay, it's gonna take a second to fire up. So now it goes. Now it's sending a lot of like transactions. It's flooding essentially with transactions, or in this case, chat messages. And it goes through the entire process. So it creates a chat message, it queues it, it creates a block. Then with the block, it sends the block out, the block gets validated, and when the block has overall consensus, which is more than 50% of the network agreeing on it being valid, then it's being added to the ledger, and then the next block is being done. So it goes through the entire process, basically. But yeah, seems like, okay, might be already done. Let's see where the chat message is. Searching for the test message. There we go. 498. So in 60 seconds, we confirmed 30,000 transactions. So, and that was done in JavaScript, and it went through the entire process. So yeah, those are pretty good numbers, right? It's not 8 per second, and it's on JavaScript. If we were going even a little bit lower, like obviously there would be some addition maybe if you add more nodes to it. So if you had 50 nodes or 100 nodes, then like the speed could be different. And I didn't have that tested yet, but for a local test, that's already pretty good. And I have the very similar numbers when I use another computer on the internet as a second node. So where like 2 nodes, my local machine as well as the one that's on the internet, has to confirm it in order, or has to validate it in order for it to be confirmed, right? So where you need 2 machines. And the speeds were actually pretty much the same. So I didn't see it break down to suddenly far lower or something. But yeah, only more testing would tell to how much that stays true. So once you add like 10 machines, each having like a voting weight of like 10% or something, how long it would take then, right? But yeah, I think those are pretty good numbers already. And it was mainly also like going to Blake 3, which made a big difference. Before it was about 100, and the change to Blake 3 was really like increasing it 5-fold. So, or even more maybe. So yeah, so much for the speed test. And yeah, peace out.